squared plus 4 plus cx. Does that look right to you? Cx squared. That look right to you? I multiplied through. You always multiply through by whatever this denominator is.
Why is it not cx plus d times x squared?
Oh, it is. I don't know.
I don't know.
Yeah, I've used that before. Thank you, Travis. Okay. Now we go through and we multiply it out and we live by our wits and decide what we can do. So I get x plus 1 is equal to ax squared plus ax plus bx to the third plus b plus 4b plus cx to the third plus dx squared. Is that right?
No. 4a.
Well, I mean, let's see.
Maybe 4.
Yeah, 4xb. Good. 4. D. 4. Okay, and then
Just a times.
yeah. My thinking cap on a times 4, b times 4 times x. Okay, then that means that bx cubed. Nope. That means that b plus c times x cubed, that's this one and this one, plus a plus d, I could go ahead and use d, plus a plus d x squared plus 4bx plus 4a. 4bx, 4a, and the x squared. Then nice things begin to happen in that I know that let's see, 4bx plus, I got 4bx, where'd that 4x on the end come from?
It's supposed to be 4a.
4a, thank you. That spreads it out nicely for us, 4a. Okay? What does that tell you? Well, nice things begin to happen, don't they? In that 4a is equal to 1, huh? Is that right? Coefficient of x to the 0 power on both sides, is that right? So a is equal to 1/4, then I know that A plus D is equal to 0. How do I know that?
Because there's no x squared.
No x squared. But A is 1/4. So that tells us that D is equal to minus 1/4. Okay? But now the same thing's happened with the B's, in that I know that 4B is equal to 1. Is that right? So B is equal to 1/4. And then B plus C equals 0, which means that C is equal to a minus 1/4. Look right to you? Everybody? Now, that means then that I is equal to the integral of, is equal to 1/4 times the integral of 1 over x squared dx plus B, which is 1/4 times the integral of 1 over x dx plus then cx, so this is 1/4. No, I won't make it a negative, I'll just make it 1/4 times the integral of minus 1 plus 1 over x squared plus 4 dx. No. I should have known we weren't going to get off that light. Both C and D are negative, huh? Okay? Everybody agree? So now I just begin to integrate. I'm going to call this I1, this I2, and this I3. And I'm going to say that I is equal to 1/4 times I1 plus I2 plus I3. Didn't that take care of all those 1/4 out front at one time? So now I1, it's okay with me if you just tell me that I1 is equal to minus 1 over x plus c. Can't you do those in your head by now? It's equally okay if you tell me that I2 is equal to log x plus c. I don't need to make you write it down if you're going to just write it down and then integrate it. And if you have it this well organized, where I know where it came from, that's good enough. If you make me hunt for it, it's not good enough. Okay? Now, I3 is where the problem comes. Not much of a problem. I3 is equal to minus the integral of 1 over x squared plus 4 dx. And here's where that handy dandy 3x5 card comes in.
Is that a 1?
Where, no, it's a 2. Thank you. Thank you. 1 over x squared, what's that? Look at your card. Have you started making your card out?
Inverse tangent.
That's inverse tangent, isn't it? So now I have minus 2, not over, and that minus 2 inverse tangent of x plus c. And then my father's great saying applies here now. It's all over but the shouting, isn't it? And that is, now we just put them back in and say that I is equal to 1/4 times I1, which is minus 1 over x, I2, which is plus log x, I3 is minus 2 tangent to the inverse tangent of x plus c. Does it matter whether, yes sir?
On the third integral, contours up the top, we have -1 minus 1 over x squared plus 4. Since it was cx plus d, would it be a -1x minus 1? Up towards top left, plus 1/4 integral -1 minus 1 over x squared plus 4, would it be a -1x minus 1, since it's cx plus d?
I think so. I think you talked me into it, Nicholas. But it's easy to talk somebody into something if it's right. I left the X off, didn't I? Well, all that does is that makes it even easier to integrate, doesn't it? So this, thank you. So this is minus x right there. And that gives us, this one's okay. No, I'm not going to do that. I'm going to fix it and say, that's minus x, but I had the minus out front already, didn't I? Beth, I was right a minute ago. Entirely by accident. X plus 1, right? Okay. Now, we got to work a little bit harder, don't we? All right. So, but this is equal to minus the integral of x over x squared plus 4 dx, right? And then minus the integral of 1 over x squared plus 4 dx. that right? The first of those two integrals is pretty easy, isn't it? It looks to me like all I need is a 2 in front of that x, and I've got 1 over u du. Does everybody agree? Seth, are you okay with that, or do you want me to write out u equal? And don't hesitate a bit to tell me to.
Go down u equal.
What?
I want to go down u equal for me.
Okay. Okay? So I think I can put a 2 right. No, I don't. If you do it, I'll be unhappy with you for doing it. So I think I can. This is I4, and this is I5. So I4 is equal to then minus 1/2 times the integral of 1, I felt it when I did it, is equal to is equal to 2x over x squared plus 4 dx. And that then is equal to minus 1/2 times the log of x squared plus 4, is it not? Don't you have the derivative of the denominator in the numerator? Okay. Now I5 is what we got a minute ago. I5 is equal to minus inverse tangent of x plus c. Agreed? And that means that, and then I3 is equal to I4 plus I5. So then I is equal to, try it again, minus 1 over x plus log x minus 1/2 log x squared plus 4, and then minus inverse tangent of x plus c.
The one that I have here, it says 1 over a times the inverse tangent of x over a, or it's a squared plus x squared. Would that mean that it's...
Would that mean that we, oh, yeah,
You're doing x squared plus 1 instead of x squared plus 4.
I sure don't remember it that way, Travis.
1/2 tangent over x over 2.
Let's look. Exactly right. That's what I get from doing it by memory. So, thank you, both of you. X over 2 right there. Is that right?
Yeah.
And then a minus 1/2 right there. Thank you. They get for doing it from memory. I think I remember that
It's all times a fourth, isn't it?
say what now?
It's all multiplied by a fourth.
Oh, yeah. I guess I like that as much as I thought I would. Because that gets it away. I guess I'll move it over there and get it out. I remember one sort of like that being on the test. Okay? Anybody, usually I make a class pick them, but since there's just 4 of us, well, 5. Anybody want to pick? Anybody want to describe one you want me to do? Yes, sir.
Is there gonna be one with long division in it?
Yes.
Can I see one of
Okay. I found 2 that have long, 2 that have long division in them, and I can't tell any difference between the 2. So I'm just gonna pick one. This is page 509, number 98. And this is no, 98's not good. That's not one, it doesn't need it. What was my other one? 78 does. And that is I is equal to the integral of x cubed over x squared minus 2x plus 1 dx. Does everybody agree by our rule that's a candidate for long division? The 3 is higher than the 2, right? So now from here on, we're going to do it exactly the way you learned to do it in the 3rd grade. We're only going to look at the first terms. You only look at the first terms, and then you let the chips fall where they fall. Okay? Beth, do y'all teach this in 98? So we're supposed to teach it in 102, I guess.
We touch on it in 99.
Oh, I meant 99,
Yeah,
dadgummit,
okay,
in
yeah.
99. But if a good student comes to us and takes 102 and we don't happen to teach it in 102, then they likely have seen it in high school, but that's a long time between high school and Cal 2.
Yeah.
I'll be more careful about that. We've changed it. I tell y'all, we've changed it for engineering majors. We put in a Math 111 and you take the sequence of 111, 112 before you take calculus, unless you place it in the calculus, and not a lot of people do. What I'm telling you is instead of taking 102, you take 111, then you take trig, and you do it in one semester, the BC deal, and that gives you a full semester of algebra and trig, 2 full semesters in one to start calculus. I believe it's going to help. This thing's out of line this morning. Yeah, I waited too late to turn it off. Okay, I look only at the first terms, and I asked myself, glad I saved it. I asked myself, what do you multiply x squared by in order to get x? And the answer is x, right? So I have x cubed minus 2x squared. Minus 2x squared plus x. I did it the same way that you learned to do it in the 3rd grade. Now, what I also do is, what you learned to do when you had decimals, is I just add zeros where I need to. You do agree that x cubed plus 2 zeros is still x cubed, right? Now you subtract, and do you remember you subtract? So when you subtract, don't you get 0 minus a minus 2x squared? So that is 2x squared minus 1.
Should be an X.
Hmm?
Should be an X, not a 1.
Say what?
Should be an X, not 1. 1 times X.
And I have minus x. Okay, sorry. Everybody agree? Now I look only at the first terms. What do I multiply x squared by in order to get 2x squared? Obviously 2, huh? So I do plus 2, and then I have 2x squared minus 4x plus 2. Now watch what I'm doing. I'm doing again what you learned to do in the 3rd grade, and that is you can add as many zeros on there as you want to, right? And I'm bringing down, isn't that the way you learned to do it? I'm bringing down the next term. So I have plus 0. And now I subtract, and I have minus x plus 4x. What look that way to you? And that's 3x minus 2. And then you ask yourself the same question again, and that is, what do I multiply x squared by in order to get to 3x? And let's just keep it simple. You quit when you would have to multiply it by a fraction. So we quit. And you remember, again from way back there, isn't 3x minus 2 called the remainder? So then with that, I'm going to say that I is equal to the integral of 3x minus 2 that's not so. The integral of x plus 2 and then plus 3x minus 2 over x squared minus 2x plus 1. Is that right? Is that right?
We need to do the partial fractions now before we can integrate it, right?
I'm thinking about, does everybody agree I need 2x minus 4 in the numerator? If I had that, I'd be in business and wouldn't have to even do partial fractions. Do you agree? But I can't get that, can I? So I'm going to have to use partial fractions. Okay? So here's what I'm going to do. I'm going to say that I is equal to x squared over 2 plus 2x excuse me, plus I1. What do you think? There's no need of calling it I1, 2, and 3, is there? Everybody agree? So, now all I need to do is do I1. So, I1 is equal to, let me put it over here. I'll save room to put my answer. But I1 is equal to the integral of 3x minus 2 over x squared minus 2x plus 1 dx. And then from here on, aren't we back in our usual mode? Everybody? So now I have 3x minus 2 over x minus 1 squared. Agreed? So that then is a over x minus 1 plus b over x minus 1 squared. Agreed? So now I have 3x minus 2 is equal to a times x minus 1 squared plus b times x minus 1.
Why is it not just a times x minus 1? It'd just be.
Travis, you're right. I was asleep at the switch. That is, if I'm multiplying everything by x minus 1 squared, that's what I get. Okay? That helps us, doesn't it? Because I can let x equal 1 and I get 3 minus 2, that's 1, is equal to b. Agreed? So now, how about if I try one of my tricks and just say, let x be equal to 0. No, I don't want to do that anyhow. I'm going to now substitute that in, and I'm going to say 3x, this is a better way to do it, is equal to ax minus a plus 1. That cleans it up, doesn't it? So now I've got 3x minus 3, you think that's right, is equal to ax minus a. And that tells us that a is equal to what? 3. So now I1 is equal to the integral of 3 over x minus 1 plus b over dx plus the integral of 1 over x minus 2 squared dx. Okay?
X minus 1.
Is this 3 times the natural log of x minus 1? And then this is this minus 1 over x minus 1 plus c. Let's see if you can do it in your head with me. Usually, by the time students reach this far in Cal 3, some of you, most of you, particularly the four of you, would be comfortable enough doing that. I'm imagining that's 1 over u squared. And if I do that, I can add 1 to that square, and that made it a -1, right? So there's the -1. And then I divide it by a -1. And usually what happens is you've done that so many times that that's one you just know, like multiplying by the exponent divided by the new exponent. You don't even think that. If you see 2x cubed, you just write 6x and you don't even think about the rule anymore. You follow what I'm saying? And then now I is equal to x squared over 2 plus 2x plus 3 log x minus 1 minus 1 over x minus 1 plus c. Are we okay with that? That's good we did that little review. I don't want you to miss long division. Long division is certainly not hard, but it could be tricky if you hadn't seen it in a while. And I don't want you to miss it. What else you want me to do? I'll stay as long as you want. I'll quit whenever you've had enough. And if you get ready to go before the rest of the class goes, that is, if you think, well, I've seen what I need, by all means, you're free to go. And I'll stay as long as anybody wants to stay. So what else would you like to see? You tell me, you describe it to me, and I'll help you find a problem like it. Anybody?
About like a trig substitution one.
Yeah, that's a good one to sort of brush up on, huh? Okay? And now I think there are 2 of those on the test.
Are there any, going to be like number 25 on page 470?
470, number 25. Well, there could be, but I need to work a trig substitution one, don't I? So I'll just work that. How about this is 8-3, which is trig sub. How about if I work number 26? Because 26 looks like it's a little harder than 25. Huh?
Right.
Okay. So number 26 on 470. So just for the record, doesn't that denominator say multiply x squared minus 1 times itself 5 times, and then take the square root of it. And that's all we're going to do is talk about it. We're not about to do that. And that's why we do trig substitutions, right? Okay? So, do you recognize that as a secant? If you don't, you should. You need to say, go back and look at my class notes, and you will find when we did trig substitutions, I gave you 3 rules of how to recognize them. You want me to write them down for you again? Or can you find them? Have you got them? How about it? Do you guys have a book and just didn't bring it, or do you use the one online? Just Travis and Nicholas.
I just didn't bring
Okay, so if I give you a page number, it's okay, huh? It's on page 467. Write yourself a note. 467, under and the triangles. Page 467, under the triangles. And it says, I circled it in red and put a star by it. Under the triangles, it says, if you have this, if you have this form in the problem, then you use this. And that's what you need to have on your card, is so you recognize which one to use. Okay? I knew that that was secant because I knew that, look at the denominator. I knew that secant squared minus 1 is equal to tangent squared. If you can look at it like that and tell, you don't need to put them on your cards. Okay? So what I'm going to do, I'm going to say, and this, in the problem, I believe it was a square, wasn't it? Okay? So I'm going to say that I'm going to say that secant theta, well, I'm going to let x be equal to 1 secant theta. And that is the card says a secant squared theta, and in this case a is 1, right? Everybody agree? So x squared is equal to secant to the 4th theta. Do we agree? And now we're ready to substitute in. Everybody agree?
Now, wouldn't x be 1 secant theta?
What?
X would just be 1 secant theta.
Yeah, now what I,
You got secant squared?
oh,
Secant instead of secant squared.
I'm off today. Okay. Now substitute in and say that our integral I is equal to the integral of secant squared theta over secant squared theta minus 1 to the 5 halves power, and dx is equal to secant theta tangent theta. Did everybody agree? Times secant theta tangent theta d theta. Okay? But we know that this is tangent squared theta, right? Now, I'm gonna write it and you tell me why I can do it. I'm gonna be careful to get it right too, so I don't mislead you.
Skip step.
I'm gonna let them tell me that step. That's what I'm doing.
Just multiply by
Didn't I say, didn't I really have from here, didn't I have tangent squared theta to the 5/2 power? And when you raise it to a power, don't you multiply the exponents? Now I'm okay? Okay? So now I'm going to say, let u be equal to, funny how it always goes back to my 6 rules, doesn't it? Let u be equal to tangent theta. Then du is equal to secant squared theta d theta. What did I do?
where it's secant theta tangent.
I said I wasn't going to mislead you. I'm going to leave that like that, and then I'm going to leave it like this. Thank you, Travis. Now what?
Just multiply, divide.
Well, let's see. I think I can do this. I think I can say that this will make that a 4. Is that right? And I think I can say that du is equal to secant squared theta d theta, right? So I think I can say, if I put these two together, that's du, isn't it? Agreed? And then doesn't that leave the integral of secant theta over tangent to the 4th theta d theta. Am I right?
U to the fourth du.
Yes. Trouble is, here's the trouble. I think what I'm going to do is this, I may use that, but I think right now, I think I want to do that for right now. It looks like I'm obviously headed that direction, but I might want to play with it a little bit with trig functions before I do anything. Here's the problem. I can't get u to the fourth du now. Yeah, I can.
Would that be secant cube?
Yeah, if I do that, the secant, it'll be secant cubed, and that'll be secant cubed up here. But then, in order to do the u's, I'm still going to have u to the fourth, and then I've got a secant left over up here, don't I? You see my problem? If I were to change tangent to secant squareds and have the whole thing in secant squares, then I'd have to multiply it out 4 times, and I don't want to do that. You know what I do when I get in a case like this? If I were working it on a piece of paper, you know what I do?
Put it in terms of sine.
What?
Put it in terms of sine and cosine.
Exactly. Because don't you see it better in terms of sine and cosine? Everybody? So let's try this. This is equal to the integral of 1 over cosine squared theta, cubed theta, isn't that the secant cubed? Is that right? Times cosine to the fourth theta over sine to the fourth theta. Of course I know that the tangent sine over cosine, right? But the tangent was in the denominator, wasn't it? So wouldn't I just invert? Now we're talking. Now we're talking. Do you see how we get out of it now? And now, and I left off my d theta, I got so excited. And now we have the integral of cosine theta over sine 4 theta d theta. We would have eventually come to it if I hadn't have changed everything to sine and cosine, but it just jumps out at me more when I get in sine and cosine. Now we know what to do, don't we? And it's not this. Okay? So now I say, let u be equal to sine theta, and du is equal to cosine theta d theta, which is exactly what we have, right? So this then is equal to the integral of 1 over u to the 4th du. Everybody, is that right? Everybody okay with that? Which is equal to minus 1, well, that's equal to minus 1 over u to the 3rd plus c. Is that right?
Minus 1/3 u to the 3rd.
How about that? Is that right? Okay. So now I is equal to minus 1 over, and u is sine theta, sine 3 theta plus c. And working it, am I right? Did I do something wrong? What? Oh, yeah, I gotta go, do what? I gotta go back to x, right?
3 and 1/3.
I need a 3 though, thank you. Oh. Okay? And now, one last step is, but I is really equal to, and I know what secant is, right? I know that, let's see. I know that secant theta is equal to x. Is that true? And I know that 1